Okay, so hi everyone, my name's Alex, and this is going to be another video, another science or chemistry video that I'm going to do. And for this video, I'm just going to explain radiation, the basics of radiation, what it is, and I think as well alpha radiation. And then in the other videos, or the next video, or next two, I'll explain what beta radiation is and what gamma radiation is. So let's get started. So radiation is known as the emission of energy in either the form of waves, electromagnetic radiation, or particles. So what you'll find is that alpha radiation and beta radiation are made up of particles, whereas gamma radiation is made up of waves. So alpha radiation is made up of, I think it's helium nucleus particles, or just helium particles, because it's got 2 protons and 2 neutrons. Beta radiation is made up of electrons, and gamma waves, or gamma radiation, is just made of waves. So let's continue. So radiation can be produced by radioactive decay, such as alpha decay, beta decay, etc., and chemical reactions and gases. There's lots of types of radiation, such as heat, radio waves, visible light, and microwaves, and these can be found on the electromagnetic spectrum. Also, these types of waves or radiation do not contain enough energy that they can pull electrons away from atoms, and this is why they are called non-ionizing radiation. So if these types of radiation did have the power to pull away electrons from atoms, that would be called ionizing radiation. And examples of that are alpha radiation, beta radiation, and gamma radiation, whereas radiation such as visible light, heat, and radio waves are non-ionizing because they aren't powerful enough to take electrons away from the atoms. So the electromagnetic spectrum, so on the left you'll see low frequency and a long wavelength. So from the left you have the radio waves, the microwaves, and the infrared, and this radiation has a low frequency and a long wavelength. These radiations on the left aren't really that dangerous to humans, whereas the radiations on the right, such as ultraviolet, X-rays, and gamma rays, can be dangerous to humans, but they're also can be extremely good because they can destroy cancer cells within the human body, and that's why a lot of the high-end radiation, the high frequency but short wavelength radiation, is used in cancer treatment because it can destroy the cancer cells but doesn't destroy the human cells, or if performed properly it won't destroy the human cells. So as you can see, there's a low frequency, long wavelength, radio waves, microwaves, infrareds, and high frequency, short wavelength. A short wavelength is just, if you imagine like a sine wave, it's going to be a short wavelength, but it's going to be lots of waves, whereas if you have a long wavelength, it's going to be longer waves, but less waves. So alpha radiation, or an alpha particle, is the least penetrating of the ionizing radiations and can be absorbed within a few centimeters of release. It takes the form of a helium nucleus, as it has 2 protons and 2 neutrons, which gives it a mass number of 4 and an atomic number of 2, and the atomic number is just the number of protons, and the mass number is the number of protons and neutrons added together. So an example of alpha emitters include uranium and radium. Alpha radiation can't penetrate human skin or clothing, unlike gamma rays. So as I was saying earlier, alpha radiation is the least penetrable out of all the ionizing radiations, and it can't penetrate past human skin or clothing. But alpha particles are very large and have positive charges, and if given access to the body, i.e. via cuts through your skin. Say if you've got like a cut on your hand and you're performing with alpha radiation, the alpha radiation could get inside your body, and it has the potential to destroy atoms, which therefore destroys cells in your body, which could therefore, deteriorate your everyday bodily functions, from being able to pick up a cup to walking. It can be any type of deterioration of the cells that alpha radiation can do if it's let into the body, but it's very unlikely. So alpha radiation should be handled with rubber gloves, but should not be inhaled or allowed near cuts on the body. Have we got anything else to do? So this is just the last thing that I'm going to do, I think. So the radiation's represented. So as you can see, the alpha particle is a bunch of particles put together. So it's 2 neutrons and 2 protons. With the beta particle, it's yellow and it's a particle, and it's just an electron. And with gamma rays, as you can see, it's like a squiggly line, just showing that it's a ray. So alpha is a particle, beta is a particle, and gamma is a ray. Is that it? That's it. I'll go back to the start just for a brief. So radiation is the emission of energy in either the form of waves or particles. It can be produced by radioactive decay, such as alpha decay. There's different types of radiation, such as radio waves and heat waves and microwaves, which are non-ionizing radiation, which means that they are not strong enough to pull electrons away from atoms, whereas radiation such as alpha radiation, beta radiation and gamma radiation are ionizing radiation because they can pull electrons away from atoms and therefore making those atoms charged, and therefore they're called ions, and those atoms will have a positive or negative charge. So there's the electromagnetic spectrum from left to right. Left is the low frequency but long wavelength, so the least harmful basically. So microwaves, you use it in your microwave to heat up things. So, and then on the right you have high frequency, which is the most dangerous but has a short wavelength. But the ones on the right are normally the ones that are used the most in the cancer research things and can save lives and things like that. It's dangerous, but if it's controlled it can be really helpful to humans. So alpha radiation is made up of 2 neutrons and 2 protons, which is basically a helium nucleus. It can't penetrate human skin or clothing, but even given the chance to penetrate, or given the chance to go inside the human body via a cut, it will go inside and can destroy cells and atoms. And then just the radiation is represented. So alpha is a particle, beta is a particle, and gamma is a ray. So there's another long tutorial. Hopefully it wasn't too boring, but yeah, hopefully you've learned something. Yeah, put in the comments if you have, that's always helpful, and if not, just dislike the video and say what you think I did wrong, what I think I could do better, and yeah, thanks for watching, see ya, bye.